Hello everyone, and this is a Geek Must Have with a project build for keeping your PC awake, also known as ATTiny F15. Have you ever seen this screen on your work PC after 15 minutes of not doing something and it requires you to log back in again? You've gone into your system settings and attempted to adjust this and have found out that that particular function has been locked out to you as a feature. This is the ATTiny F15 project, which might be a solution to keeping your PC from falling asleep every 15 minutes. Now there is a disclaimer here. All of the video, including the code and everything that's inside of it, is for entertainment purposes only. Use it at your own risk. You're an adult. A lot of times corporate computers are set up to log you off after a certain amount of inactivity for security reasons. There's a piece of software called Caffeine from Z-Horn Software, which is donation-based, which basically simulated an F15 key press every minute and kept your PC awake. It was portable, which meant it didn't have any footprint and didn't require you to have administrative access to your machine. After a while, corporate groups found out about caffeine and even found a way to get rid of it. So this is an alternative solution using the ATtiny85, the USB version. It looks like a keyboard, acts like a keyboard, smells like a keyboard, and it's Arduino code controlled, which simulates an F15 key press every 15 minutes. And there is some consideration need to be given to the authentic DigiSpark versus the clones. Here are some of the technical specifications of the ATtiny. It's called the ATtiny85 because it's 8 for 8-bit and 5 for 5 volts. It can be powered through USB or an external source. It has a regulator on it to help prevent it from being blown up. It has 6 GPIO ports and 8 KB of ISP memory and 512 bytes of EEPROM and 512 byte SRAM. Also has a 4-channel analog to digital converter. It runs at 20 MIPS at 20 megahertz. Has an I2C UART and SPI communications capability. And it's a RISC, or Reduced Instruction Computer Based Microprocessing Computing Unit. And I remember back in the day having a RISC computer was a big thing. And all of that is in that little tiny package off to the right. Programming the ATtiny85 requires a little bit of work with the Arduino integrated development environment. When you install it, it has to be version 1.65 or better. Something I learned, and I should know better, the sketch folder and the name of the sketch need to be the same. The Arduino IDE doesn't know about the DigiSpark board whatsoever, so you'll have to add the DigiSpark board to it so it can recognize it. There's also a DigiSpark library with code and some examples that will need to be installed. And that library is going to have to be modified slightly to be able to use keyboard emulation properly. To get started with the Arduino IDE, you need to go to the download website. A link will be provided in the description for this. And you need to go to the download for the Windows installer. When you click on the Windows installer, the Arduino people will ask you for a donation. And if you're just using it, you're probably just going to go to the just download right here. But after using it for a while, you may consider going back and doing a contribution to them because they support this whole effort just through contributions. So it will be downloaded onto your system. And then after it's been completely downloaded, you need to click on it to start the installation. Click on the Yes button to proceed. There'll be a user license that you should agree to. You should install everything. Pick the default installation directory, and it will proceed to install. After a while, about 2 minutes, the installation will be completed, and you can click on the Close button, and you're ready to go to the next step. The Arduino installation should have installed an Arduino icon on your desktop that when you double click on it, it will open the Arduino environment and open the last package that was used. Since you're an initial user, In my case, it opens up the Blink Hello World script, which was the last one I worked on, which is a slightly different script than the standard Blinky script. You can verify the version of Arduino that you're using, and you can see up here it says Arduino 1.8.3, which is much higher than the minimum version required to use the ATtiny. The default version of the Arduino IDE does not have the configuration for the DigiSpark ATtiny board, so we will have to load the board definition as our next step. So we'll click on File, we'll click on Preferences. As a note, this is where the sketchbooks are located when new sketches are created. Down here is where the additional board manager URL are located. And by clicking on the box over here onto the right, you'll see that there are no other URLs right now. So what we want to do is we want to install the JSON file necessary to include the DigiSpark board. Click on OK, and we'll go back and just verify File, Preferences, and look at the board list, and there it is. We'll click on OK and OK, and that setting doesn't take effect until the next time the IDE starts. So we're going to close it and restart it. So we are going to go to Tools and Board. And the board has not been installed for the board definition for the ATtiny has not been installed yet. That's because we need to go to Board Manager. And here are the Boards Manager. And we are going to ask for the contributed type boards. And right here is the DigiStamp AVI board by DigiStump. We'll highlight that one and click on the Install button. And the installation has been completed. And now when we close this off and go to Tools and Board, you will now see that the DigiSpark boards are here located at the bottom, and the one we're going to be using is the DigiSpark default 16.5 megahertz. The next step is to install the driver software. We will do this by going to the following website, which is a GitHub website where the repository is kept for the when this opens up, we are interested in the digistump driver.zip file that's located right here. So by clicking on that, that file will be downloaded to our PC, and then we will open the file up and ask that the information be extracted to a file directory we have on our system named transfer. And we'll do the extract. Extract has been done. And now when we open up this directory, you will notice a DP install, which is for the 32-bit, and the DP install 64, which is for the 64-bit, which is the version of Windows that I'm running. So I'm going to do that install by clicking on that. I will confirm that I want it installed. Go on next. It will ask if we would like to install the drive, the device driver, and I'm going to say yes. And there are the device drivers listed there. And all we've done now is install the drivers onto our Windows system. It's probably a good idea at this time to verify that the ATtiny actually works in this environment. So we'll check a few things first. We'll go to Tools, and we'll verify that the board is being listed as the DigiSpark default at 16.5. And the second item is that the program is the micronucleus. That's the programmer that's used to actually program or download the code onto the ATtiny. Let's attempt to upload this sketch to the ATtiny. So we'll click on it, and it's compiling the sketch right now. And then it downloaded the sketch. Or it's waiting now for us to connect the device. Which what I'll do is I'll connect the ATtiny. And there is the light indicating that the script's being downloaded. And it's been downloaded. And now that sketch is running. And Blink is running. This verifies that our environment works. We are now ready to actually start working on the IM15 sketch. We have loaded the IM15 sketch in its completed form, and a link to this on GitHub will be provided in the description below. This particular script uses the DigiKeyboard library, and the full documentation on that library can be found at the link shown here. There are a couple of changes to the libraries that need to be done to handle this. We'll go over them a little bit later, but let's look at the actual sketch itself. Here is where the DigiKeyboard, the DigiKey library is being invoked. And the opening part of this is I decided to put a confidence message in here where I would open up Notepad and then type a message to let somebody know that the actual IM15 is running. So to do that, first thing we do is clear out the keyboard by sending a keystroke 0. We wait 50 milliseconds. Then we move on to pressing the left Windows key and pressing the R, which will invoke the run command. We'll wait 100 milliseconds. Then we'll hit the delete key. The delete key will clean out anything that's in the run menu. We'll wait 3 milliseconds, and then we'll put in Notepad, which will start Notepad. And if you notice that the print LN indicates that it'll end with an enter, so it'll automatically click on the enter. We'll then wait 2000 milliseconds, which should be enough time for Notepad to launch. And then it will display, I am your F15 key. I am here every minute for you. I will keep you active. And then you can close the Notepad at any time. The heart of this code is not just that, it's this next chunk of code that gets run in a loop endlessly. So the keyboard key, Shift F3, is actually the F15 key. And that key was picked because it doesn't appear to interfere with many programs that I am aware of. After some testing, I did find out that there are some programs that actually use that this caused a problem with, but the majority of programs it won't. So the DigiKey will now use the send key stroke to send the Shift key and the F3 key together. So the send key stroke actually holds the two keys down together, which is the equivalent of the F15. Then it will wait for 60,000 milliseconds, which is effectively 1 minute. And it will continue to do this forever. The standard DigiStump libraries, including the keyboard library, need a couple of small modifications I found out in order to get it to work. The very first one is changes needed to be done to include the delete key, which was not in the keyboard library. I don't know why the delete key wasn't there, but my username is jshoes2, and the directory you want to go to is indicated here, and it's a real long directory, and it ends with DigiSpark keyboard.h, and that's the file that we need to make the change to add the delete. So if we switch to the digikeyboard.h file, this is the standard file, and you'll notice I added a comment here to indicate that it was modified by me. And we are going to scroll down to the code. Right there. And here's where I added the key to define the delete key. I called it key underbar delete, and it happens to be the code 76. That's the only change that needed to be done to the digikeyboard.h library file. The next file in the DigiSpark libraries that needed to be changed was a file that's the USB config.h file. And the reason why this file needed to be changed is because of the characteristics of USB devices. All USB devices have a VID, which stands for vendor ID, and a PID, which stands for product ID. Now the default VID and PID that comes with the USB doesn't get changed until after the actual sketch gets loaded. And in some Windows machines, that's a little late for it to be able to load what it thinks will be the necessary drivers for this. So to get around the problem, I looked around and kind of back engineered and found out that VID 046D and PID C52B are the vendor ID and the product ID for a standard Hewlett-Packard keyboard, which will cause when Windows sees this device, for it to load the drivers for the standard Microsoft keyboard, which is typically accepted by almost all computers. So this made the USB device kind of look transparent in corporate networks rather than looking suspicious by not having the correct VID or PID. So we need to change that USB config.h file. And this is the USB config.h file. I made a note again here that I made a change to this. And we'll scroll down to the point where that's at, and it's device descriptions right here. So here are the device descriptions. Again, I put a note down here. There it is, 046D and C52B. So those two changes are done partially up here for the USB configure vendor ID and the USB device ID, which is also known as the product ID. So these are the only two slight changes to help the USB device look more like a keyboard. Now's the time of truth to see whether the IM F15 sketch really works. So we will go to the load for the sketch. The sketch will be compiled, and it will ask us to plug in the device. And when we do, the light will indicate the card's being powered. The script has been uploaded. Notepad is opened. And the confidence message: I am your F15 key. I am here every minute for you. I will keep you active. You can close the notebook at any time. Close this out. And in the background, the DigiSpark is now pressing the F15 key once every minute. This will keep your PC awake. And hopefully, you will not see the login screen after 15 minutes of inactivity.